Right, so we are back again, but this time with the derivation of ionization constant for a weak base, that is Kb, and that weak base we are going to consider is aniline. As we did in the previous episode, a weak acid ionization constant, and before that we took self-ionization of water. With the same series we are proceeding with the weak base, that is aniline. Now you know very well, a weak base means a compound which will ionize partially, and for you right now I am writing aniline, that is C6H5NH2. I am reacting this compound aniline with water, and as a result, you know, as it ionizes partially, fine, automatically on the right hand side will form its ionized ions. Which are those ions? Let us understand. Water ionizes equal into H ion and OH ion, fine. With respect to that, the lone pair of electron present on nitrogen will attract, or you can say try to pull the proton from water towards it, and as a result we will have C6H5NH3 plus, and what is left out is OH minus. So these two ions formed will recombine and they will give us the original reactants in the form of aniline and water. So this is an equilibrium which is established. Now I can say initially the concentration of aniline, let us consider, is CO. Then with respect to that, initially nothing will be formed. Now suppose a dissociation takes place, and that dissociation is, let us say, X moles for aniline. With respect to aniline, water will be not considering because its concentration is 55.55, and as aniline dissociates into X moles, with respect to that, this cannot be considered. So if X moles of aniline has dissociated, it implies it has converted into anilinium ion and H ion, and those will be the same as in the case of aniline. So dissociation for aniline is X, automatically the anilinium ion and the hydroxide ion also dissociates, forms equally. Now at equilibrium, we will have this as CO minus X, this is X, and this is also X. So this is what at equilibrium state will get. Therefore, the equilibrium constant can be derived as KEQ barabar concentration of products to that of reactants. What are products? Products is C6H5NH3 plus and OH minus. Reactants are aniline, that is C6H5NH2 and H2O. Out of all this, water is in excess, we'll take along it with a constant, that is KEQ into concentration of H2O, and that is equal to the concentration of products to that of reactants. So it is C6H5NH3 plus OH minus, and we have C6H5NH2. Now KEQ into water gives us a new constant, but this time the constant is for a weak base, and that's why we'll write it as Kb. Therefore Kb is equal to, now what is the anilinium ion at equilibrium is X. For OH ion is also X, and for aniline it is CO minus X. But you know, as we discussed in the last episode or previous episode, that compared to the concentration, the dissociation is quite less, very negligible, and so we neglect that term, and therefore Kb will be X square upon CO. Or we can write X square is equal to Kb into CO. Fine. What is X over here? For X we have got anilinium ion as well as OH ion. Fine. But for any weak base, of course here we have taken aniline, but you can go for amines. For example, NH3 is ammonia. You can go for RNH2, any alkyl amine. You can go for hydrazine, NH2, etc., etc. type of weak bases. Everywhere the X will remain the same, that is nothing but OH ion, and therefore for X we are substituting the OH ion over here. So OH ion square is equal to Kb into CO, or I'll write OH ion concentration is equal to under root of Kb into CO. So this is how we can derive the OH ion concentration for a weak base like aniline. Okay, now I have one question, as I had in the previous episode, that aniline is a weak base. We have derived its OH ion concentration. Fine. Okay. My question is that even though it's a weak base, I want to derive not OH ion, I have derived H ion concentration for aniline. Not OH ion, mind you, H ion, H plus ion concentration for aniline. Then is it possible or not? Work it out and just practice more and more to find out the solution for this question. Obviously, you will get the answer in my next episodes, but at least try it on your own, and then if you are not able to, you can just watch the next episode. Till then, goodbye. Do take care of yourself. Obviously, you must have subscribed. If not, it is Saurin.S.Mehta Chemistry for upcoming videos. And if you have any doubts, you can go to styrene, STYRENE 1411 @gmail.com. Till then, goodbye.